So welcome back students to one more session of your structure of atom. So basically I've been doing all the NCERT numericals all these days, isn't it? So now I've decided to do the Bahadur numerical chemistry. That's a very famous book, physical chemistry book for you, which is prescribed. So this will be useful for your cbse as well as your JEE as well as NEET. So from now, whichever chapter I do, I'll try to finish off the NCERT numericals as well as Bahadur numericals also, right? So here in Bahadur numerical chemistry, you have a very clear cut. It's a combination of all the types of numericals. So let's start solving it. I've picked up the structure of atom chapter, so I'm going to do the numericals for that. Fine. So in Bahadur numerical chemistry, let us read the first question. What do they give us? Nucleus of an atom has 6 protons. I'll be doing all the basic numericals also, right? The nucleus of an atom has 6 protons and neutrons, okay, and 8 neutrons. Calculate atomic number, mass number, and number of electrons in the neutral atom. What is the symbol of the element? So all the topics are there at one stretch. Yes. So let us start solving the numerical. Let's see how are you going to do. So I need to calculate the atomic number, mass number, and number of electrons. First of all, I have to start with the solution. What actually is this? Atomic number of the element. Okay, atomic number of the element. What is it denoted by? It is denoted by Z, isn't it? Atomic number is always equal to number of protons, correct? Yes. So number of protons. So what is Z now? Z is equal to how many protons are there? 6. So that's done, isn't it? So atomic number is 6 over. Next comes your mass number. So we very well know mass number of the element. Which alphabet it's denoted? It's denoted by capital A. So that is equal to, mass number is equal to number of protons plus number of neutrons. This is the formula, isn't it, which we have studied. Number of protons plus number of neutrons. So what is it equal to? So A is equal to, what is number of protons? 6 plus 8, isn't it? So 6 plus 8, that is your 14. So your mass number is 14. That's it. Now I need to just write now number of electrons, because this is over, number of electrons. So when I have to do the number of electrons, how do we do number of electrons in this, right? So number of electrons is in the neutral atom. So this is important, in the neutral atom. Fine. So what is the number of neutrons in neutral number of electrons in the neutral atom? It's because an atomic number of the element, number of protons or number of electrons. Here this indicates number of electrons also. Fine. So protons should be equal to electrons, P plus and E minus. So number of electrons is 6. It's the same, isn't it? Yes. Now what is the symbol of the element? I need to write the symbol of the element also. Come back to this and write the symbol. So basically the element with number 6 protons, or the atomic number, or always we know how do we write? We write if I take an element. Suppose let me take an element symbol, some element A. Atomic number will be mentioned here down, that is Z. The mass number will be mentioned above, isn't it? So now what is Z in this case? Z is nothing but 6. So what is mass number A in this case? It is your 14. So what is that element with atomic number 6? It is nothing but carbon, isn't it? So we have written the symbol of the element as carbon 12, and the isotopic form rather it is 14. Fine. So this is how you are going to do your numerical. So hope this is clear. Atomic number, this is the formula. Mass number, this is the formula. Number of electrons, okay, in the neutral element, number of protons and electrons are the same. And symbol, finally you will write always the atomic number below and mass number above. Now let's come back and start with the next numerical in Bahadur chemistry. So hope the concepts are getting cleared. Again, it's a complete revision of the chapter. So when I have to do this numerical, what do they give me? Uranium has an atomic number 92 and atomic weight of 238.029. Calculate the number of protons, neutrons and electrons in the uranium atom. So all the 3 are there in the same numerical, isn't it? So how do we do this? Basically, first of all, let us write with atomic number always, because copy the information which is given to you. So let us write atomic number of uranium. Okay, how much is atomic number? Atomic number is nothing but 92. Okay, right. So what did we say in the earlier thing? Atomic number, that is equal to number of protons or number of electrons. This indicates number of protons and this indicates number of electrons, isn't it? So write down. They have asked me to write number of protons. So I'll copy the same. Number of protons is equal to 92. Now what is number of electrons? It is also number of electrons also is 92, isn't it? Yes, this is also done. Fine. So now what else is there? I need to write number of neutrons. So there's also one formula. Next, this part is over. Let us take this is 1. I'm coming back to the second part. What is mass number now? So mass number is like always, what is this? Mass number is atomic weight, means the mass number of the integer value, means it is a higher part, isn't it? So mass number given to me is what? 238.029. Okay, fine. So we have, what is mass number denoted by? This is capital A. Atomic number is denoted by Z. What is the formula which we have? A is equal to Z plus N. This is the formula, correct? Yes. So now I want number of neutrons. I got protons here over, I got electrons here over, I need to get neutrons. So from this formula I can get neutrons out, isn't it? Get this neutrons, this part here, come get this here. So what do you get? Neutrons is equal to sorry, A minus N, correct? Sorry, A minus Z. I'm sorry, A minus Z. So what do you get? So N is equal to, what is A value here? 238.029 minus Z value, that is number of protons and number of neutrons, 92. So number of protons and electrons. N is equal to now 146. This is the answer. So this is one answer. This is the second answer. This is the third answer. Protons, neutrons and electrons. That's easy, isn't it? Right. Now let's come back and do one more numerical. So what does the sum want us to do here? They said calculate the number of electrons which will together weigh 1 gram. I need to calculate the number of electrons which will be there in 1 gram. Okay. Next is calculate the mass and charge on 1 mole of electrons. Okay, simple. Let us start with the first one. I'm solving the first one. Calculate the number of electrons, they said. So how much is that number of electrons in 1 gram? So basically when I have to speak, what is this one of weight of one electron test? Nothing but 9.108 into 10 raised power of minus 28 gram is equal to 1 electron. Correct? Because this is in gram, isn't it? They want us to find for gram. Right. That is the weight. So what can I write from here? So 1 gram is equal to, fine. So how much? 9.1 is so many electrons. So 1 gram can be how many electrons? Now cross multiply, isn't it? So what do I get? 1 divided by 9.108 into 10 raised power of minus 28. How much do I get? I get an answer of 1.097 into 10 raised power of 27 electrons. Okay, this is the amount present in 1 gram. That's it. This is the answer. Simple. Take the standard value and find out what is required. Now in the second one, when I start, I need to calculate the mass and charge on 1 mole of electrons. So now start. What is mass of electron? So mass of 1 mole electron. Okay, what is mass of 1 mole electron? Just now we have written, isn't it? This weight, that is equal to 9.108 into 10 raised power of minus 28 grams. Fine. So but they said mass of 1 mole of electron. 1 mole is how much? Avogadro number, isn't it? So you will multiply the weight into Avogadro number, that is your 6.023 into 10 raised power of 23 electrons. When you multiply, you get an answer of 5.48 into 10 raised power of minus 4 grams. Okay, right. So what should I find out? I calculated the mass. This is over. Mass is over. Now I need to calculate charge. How do I calculate charge of electron? So okay, let us write again. Charge of, they've asked me mass of 1 mole of electron. I got it. I multiply with Avogadro number. Now charge of 1 mole of electron. Charge of 1 mole electron. Fine. So what is this? Basically charge of, normally see mass is this. Now what is the charge of 1 electron? That is 1.66 into 10 raised power of minus 19 coulombs. Now charge of 1 mole of electron I said. So you need to multiply with again with Avogadro number, that is 6.023 into 10 raised power of 23. Fine. So when you multiply, you get an answer of 9.99 into 10 raised power of 4 coulombs. Because this is the charge, you need to write it in coulombs. Spelling is COU, okay, COULOMB, okay, COULOMB coulombs. So hope this concept is clear. I have calculated this for 1 gram, then I calculated the mass, then I calculated the charge. This is over. So let's come back into one more type of numerical. This is a bit very big numerical. Let me use the back side of the page. So what is they give me? They said calculate the total number of electrons present in 1 mole of methane. Okay, one number of electrons. Then I need to find the total number and total mass of neutrons. Okay, then I need to find total number of protons, total mass of protons, and will the answer change if the temperature and pressure are changed? Okay, this is the concept. Now let's start calculating the first one. What is the first one? I need to calculate the total number of electrons present in 1 mole of methane. Fine, right. So let's start with the first. I'm turning this page. I'll be using this part of the page. Yes. So for the solution part, what do they give me? I need to calculate total number of electrons in 1 mole. Okay, I am calculating in this method. Just see 1 mole of methane, 1 mole of CH4. It is equal to n molecules of methane. This is correct, isn't it? So 1 mole is equal to n molecules of methane. Fine. So how much is this? What is n? How many molecules they've given? How many n molecules of methane? How much did they say? They said calculate the total number of electrons. They said so n into, okay, n into 10. Why did I write 10? 6 plus 4. Okay, 6 carbon atomic number, 6 atoms and plus 4 atoms. So 10. So here I am writing 6 n into 10 electrons. So how much is this equal to? 6.023 into 10 raised to power of 24 electrons. Okay, 23 electrons. Sorry, we get a number 23 electrons. This is over. The first part is over. So this 1 mole of methane contains so many electrons. Let me come back and solve the next question. So what did they give me? They said calculate, find the total number and number of neutrons in 7 milligrams of carbon 412 isotope. So basically, when I have to say an atom carbon, how many neutrons does it have? So when I have to solve this, an atom of carbon 14 6 has how many neutrons? Has 8 neutrons. How did I get this? Yes, I have subtracted 14 minus 6, isn't it? That is 8 neutrons. Now, so if I have to say how many milligrams did they give me? They've given me, they said the total number. Okay, find the total number. I did. Then I said total number of neutrons in 7 milligrams. Now I need to calculate for 7 milligrams. So 7 milligrams of carbon 14 and 6, right? So this particular thing, how many? This is equal to 7 into 10 raised to the power of minus 3 grams. Fine. So now let us equalize this. 7 into 10 raised to the power of minus 3 divided by 14, okay, mole. So this is equal to 7 into 10 raised to the power of minus 3 into Avogadro number, because 1 mole, isn't it? 6.023 into 10 raised to the power of 23 divided by, no, this is 14, this is also 14. Okay, this is an atom. So therefore number of neutrons is equal to, number of neutrons is equal to 7 into 10 raised to the power of minus 3 into, okay, 1.675. So no, this is not this is not 1.7. It is Avogadro number. I'm sorry. Now this one. Then this one. 6.023 into 10 raised to the power of 23 into, yes, 8 by 14, isn't it? So 8 by, because 8 neutrons they've asked me, 8 by 14. How much do I get? I get an this one of 24.09 into 10 raised to the power of 28. That's over. Fine. So now let's come back and do the second part. This is your A part. Fine. So let me see if I have some papers. Okay, I'm not left with any papers. Not a problem. Let me adjust with the space. So B part. What do they give me? Next, I need to find what one? I need to find B, the total mass of neutrons. Fine. Let's see that mass of neutrons. So in that particular thing, mass of neutrons is equal to 24.09 into 10 raised to the power of 28 into 1.65, because this is the mass of neutron, isn't it? Mass of 1 neutron, 6.5 into 1.675 into 10 raised to the power of minus 27. How much do I get? I get an answer of 40.35 into 10 raised to the power of minus 7. So I got the mass of neutron. Fine. Now my task is to find, next question is, they've asked me to find the total number of protons and total mass of proton in 34 milligrams of ammonia. Okay, let me take this page. Yes, because this is not clear, I'm just using this page for this. So in the third question, in the third part, what should I let? Okay, 34 milligrams of ammonia NH3, it is equal to, it is nothing but 34 into 10 raised power of minus 3 grams. I am converting milligrams to grams. Ammonia. Okay, how much is this weight of ammonia? It is nothing but 14 plus 3, that is 17 grams, isn't it? That means 34 into 10 raised power of minus 3, okay, mole ammonia divided by 17. How much this comes to? This comes to 2 into 10 raised power of minus 3 mole ammonia. Okay, fine. Further, if I have to write, because mole also I need to convert, 2 into 10 raised power of minus 3 into 6.023 into 10 raised power of 23 molecules of ammonia. Okay, so if I solve this further, if I multiply, I get an answer of 12.046 into 10 raised power of 23, 3, okay, 3 plus 3 and minus 3 and plus 23, so this becomes 20 molecules of ammonia. This is right, isn't it? Done. So I am done with this. So they've asked me what to find out, so I did total number of protons. Okay, total. Now I need to find the number of protons as well as mass also. Okay, I need to do that sum. So let me come back and do the next part. So here when I have to take A part, I'm doing the A part, third and A part. So number of protons in one molecule of ammonia, how many? Therefore, number of protons in one molecule of ammonia are how many? It is equal to 10, isn't it? Yes, fine. So this right. So number of protons in the molecule of ammonia are how many? 10. How did I get this? So basically atomic number of nitrogen is 7. 7 plus 3, 10. So total number of protons. We already know the this one total number together when you add. Fine. So now the next step, what should we do? So now number of protons we did. Now let us do total number of protons. So total number of protons is equal to 12 point, we got this molecules, isn't it? 12.046 into 10 raised power of 20 into 10. So how much do I get? I get an answer of 1.2046 into 10 raised power of 22. Fine, that is A part. Let's do the B part. Next they've asked me to find the mass of total protons. So I am doing the B part of that. That is mass of total protons. So mass of total protons is how much? It is 1.2046 into 10 raised power of 22 into 1.672 into 10 raised power of minus 27, because the charge of the proton. Now this is equal to 2.014 into 10 raised power of minus 5 kg. Okay, now I've calculated everything. What did I calculate? They've asked me to calculate, if I have to see the sum I need. Okay, they've asked me to calculate everything. I calculated total number. Okay, done. Total number is done. This is also done. This is also done. Mass is done. Okay, I need to answer this question. Okay, what did they ask me? They said, will the answer change if the temperature and pressure are changed? Right, so will the answer change? So basically the answer will not change, isn't it? Why? Because the mass of ammonia does not depend upon pressure and temperature. So let us write the answer. No, the answer will not change as the mass of ammonia does not depend on pressure and temperature. Okay, this is the concept. Hope the concept is clear. I'll show you everything, like hope like everything is done. I've done this question. I've done the first part in this case. Then I've taken the yes, so this part, I hope this is clear. I have taken 34 milligrams. Yes, so I've done different pages. After this part, I've done this part also. This is also over. Then I have done the total number number of protons of ammonia also. This also is done. After that, I finish off the answer with this topic, this part. Yes, now let's come back and do the fifth question. This is done for now. Let me take out this page. Let me take out this page. Let me take out, okay, this page is also over. This page is also over. Now let me do the fifth sum. So here in the fifth sum, what did they give us? They've given me nitrogen atom has atomic number 7 and oxygen atom has atomic number 8. That is understood. Calculate the total number of electrons in nitrate ion. Fine. So first of all, let us write the formula for nitrate ion. So the formula for nitrate ion. What is the formula for nitrate ion? It is nothing but NO3 minus. Correct? Right. So next important thing. Number of electrons in NO3 minus ion. So how many are there? It's nothing but, let us write. So electrons, we have both two elements in this, isn't it? So electrons of nitrogen, electrons in nitrogen, plus 3 into, this is 3, isn't it? 3 into electrons in oxygen, plus there is one more thing you should observe, plus this is one extra electron, isn't it? Plus 1. So total how many electrons are there in nitrogen? See, atomic number is nothing but number of protons or electrons, 7 plus 3 into electrons in oxygen, basically, yes, 8 is atomic number, plus 1, total 7, 3, 8, okay, it's just 32. Fine. Right, so this is a sum. Simple. They've asked me this, so take out that element and do it separately. Hope the concept is clear, students. So let's come back and do the next sum.